and welcome to another Beyond Our Value Roundtable edition. So this time we're going to be talking about building the best wall. So this is actually very exciting because we have another great panel of panelists. So I'm going to just kind of go down the line first, do quick introductions. My name is Dan Edelman. We basically put these webinars on for collaboration and education. My name is Dan Edelman. I've now been with TimberHP for about 8 months. Before that, I was with Rockwell Insulation for 13 years. And if you do have any Q&A in the chat or Q&A, please just make sure you pop it in the question section. If you do want to just talk amongst yourselves, just make sure that you're putting the panelists and attendees section. But please feel free to introduce yourself in that right now. See where you're from. We're probably from all over the country right now. And I'm going to actually introduce Bill Ryan. So Bill is one of our territory sales managers. He's going to be fielding any questions in the Q&A. And if there is anything pressing, he's going to just pop on again and ask the question. And if not, we'll basically be able to answer every question by the end in the Q&A spot in the webinar. So I'm then going to go over to Jason Todd. And Jason, if you want to do a quick intro of yourself.
Yeah, Director of Building Science and Industry Support here at TimberHP. Excited to be part of the discussion and hopefully can help answer questions with other smart people on the call.
Then, of course, we have Emily Mottram.
Hi, I'm Emily Mottram, architect here in Maine. So close to TimberHP, love being kind of local, co-authored the Pretty Good House book, and maybe you've seen me on BS and Beer, which is live the first Thursday of every month.
Yeah, and I did put your Mottram architecture and a whole lot more, because you do a whole lot more. Pretty Good House, the National BS and Beer, E3 podcast. So many ways to find Emily and what she's doing. And then Randy is very similar. So Randy, if you wouldn't mind just introducing yourself.
Sure. Randy Williams. I am not an architect. I am a building science nerd from a very cold climate, northern Minnesota, about 100 miles south of the Canadian border. I do a lot of building investigations, energy audits. Recently finished up my BPI Building Analyst Technician, which is a new certification. I had the older BA, which is just a building analyst back in 2010, but this is kind of an updated one. So now I have 3 little letters behind my name, BAT. I guess I'm a BAT now. But yeah, I just, thanks for having me, I guess. Looking forward to it.
Yeah, thank you. And we are also waiting on Matt Blomquist. So we were on site with his students. He's a trade school teacher in Taylorville, Illinois. Many of you might know him and follow him on Instagram. We were out there actually doing a double stud wall assembly that Emily Mottram designed. So that was pretty cool. And we're going to kind of get more into that. He's having a little trouble logging in, but hopefully he could actually reach out to the contact I just sent him, and he'll basically be able to get on here as well. So first, the kind of conversations that we're going to have. So because we have so many participants this time, we are going to go through kind of I call it the wonderful world of wood fiber insulation, where we're just going to kind of have a quick discussion and what wood fiber insulation is all about. Then we're going to be talking about different wall assembly options. So right now with codes, they're all over the place. You know, now the code is really more, I consider it more like a recipe book, kind of like what Glenn Mathewson, my good friend out in Denver, talks about. So there's many different options, and just trying to figure out what option is best for you, your builder, your subs. All of that is very important, and it's going to depend on where you are located in the country and everything else. And then we're going to dive into the actual project and a double stud wall, starting with the design and then the install as well from the students in Taylorville, Illinois. Jason Todd also, like he was saying, he has a cellulose background. So he's our technical guru on all things dense packing, well, even more than that, but dense packing, exterior walls, and also attic installs as well with timber fill. And then we're going to be going more, and I have a little drone footage of the project in Taylorville, Illinois, which is pretty cool. And then the Q&A. So I'm going to go ahead and just get started. So first and foremost, TimberHP. So HP in the timber part, or TimberHP, what it stands for, it's really healthy planet, healthy people, and high performance. So that's three things that we really care a lot about. So it's not just the product being a healthy product for the planet, but also the people installing it. So with our products like Timber Fill, it's a low dust install when you are blowing in the product. That's available right now. So insulation contractors, lumber yards, GSD suppliers, you name it, pretty much everybody has access to that. Then Timber Bat. So that's going to be our semi-rigid bat product. That's going to be very similar with like a mineral wool insulation in the way that it kind of comes and gets packaged. 15-inch on or 16-inch on center for wood stud and steel stud, and 24-inch on center. And then timber board, we're actually going to be releasing that in Q4 of this year. And that's going to be a vapor permeable continuous insulation. And we'll be getting into talking a little bit more about that product in some of these assemblies, along with the in-cavity installs as well. So one question I get a lot is, why would we want to use wood fiber in America? And actually I'm going to pass it over to Emily, because I want to understand why she is really wants to use wood fiber on her projects moving in.
Sorry, I was trying to help Bloomy. What'd you say?
Oh, I'm sorry. Everybody froze on my screen. So I just wanted to know why you use, or why you specify wood fiber insulation in North America.
Sure. Well, so there are a couple of reasons why I specify wood fiber. The very first one is because you guys make it here in Maine. So having a local product not only is good environmentally, you're not trucking it across the country, but it also is great for social and economics of helping our direct community, right? You guys are here, that has a direct impact on Maine. So that's a big reason for us. Two, we've been moving away from carbon intensive products. So we really like to use things that are natural. So natural wood products, things that are post-consumer. You guys are keeping this from going to the landfill, which is super exciting. So many great things about this particular product. And then we often are using some kind of vapor open insulation, because our buildings need to either drain or dry. And I sort of like the dry idea. So we often are using something that is a little bit more vapor open, so that we have an assembly that works with it. So carbon, local, community support, good for the environment. Can I say more?
And the other thing is, 99% of all the homes built in North America are actually built out of wood. We have an abundant supply of wood, and the product that we're actually producing we're not cutting down any trees. It's actually recycling wood chips. So that's something that's kind of, really near and dear to our heart, especially in the state of Maine or anywhere that there's an old paper mill, because now those paper mills aren't basically taking those wood chips anymore. Because a lot of them have gone out of business, unfortunately. So we are also, re-energizing some of these small towns in Maine right now, but that doesn't say that, with demand, we could help with other communities all around the country. It is a treated product. And just real quick, I'm going to go through these. Obviously, Emily brought up the carbon storing, high performance and highly recyclable, but it's also non-toxic and safe for everybody. And believe it or not, but it has a Class A flame spread. So it is treated with a liquid borate in the process. And that's going to basically give it a Class A flame spread. So you can actually use it in 1 hour and 2 hour fire rated wall assemblies. We do have some ESRs on that, and ESL also coming out very soon. And basically you could use that for that. Also, another benefit that's not on here is sound. So it's a very highly dense product. So that's really what's going to help it with sound. It's a dense product that's in your wall. It's friction fit. So yeah, so the factory itself, or the mill, we still call it a mill because actually, Jason, if you don't mind, kind of tell the story about why we call it a mill. You're on mute.
I often talk to myself, but probably good if I shared with others now and then. But yeah, we do call it a mill. We've got operators, an E&I team. We have millwrights, the guys that are maintenance, and I think they're well versed in many things because there's a lot going on. You can see from the outside of the building here. The blue and white building that's very prominent amongst all the heavy equipment and the cranes. They're now gone, but that was the original mill. This was a UPM. It was a paper facility, a super calendar facility. This is the glossy, shiny insert parts of the newspaper. And at one point years ago, it was 40% owned by the New York Times. That was back in the day when people actually read paper and newspapers, and we've moved away from that, not entirely, but great deal of that. It's a small lot. It is right on it's right on the river. You can kind of see that in the background, and all of our electrical generation is produced by a dam that is just upstream from this picture here. And I think maybe it's a nod to that past and the industry that was there to call it a mill. And just I like holding on to little bits of things there, and great team. Some of them coming from paper, but learning their way on wood fiber. There's a great little process video. I can continue talking now that I got my my wits about me, but you can see if you took if you took forest products that are already being produced that we're using to frame up houses, residential, some commercial as well, and the additional products that we use, pine board, trim, all sorts of things, flooring. We're making something out of a round log, and we're trying to make that into a rectangular shape. And there's always going to be waste. That waste used to go to the paper mills. That facility that you saw before, as it was, bought a lot of chips and use them in their process in the mechanical, thermomechanical pulping. We have a little bit of that we do in the process, but a lot more that goes on. But primarily, most important thing about this is that it's a waste chip. We're using that byproduct, recovering it, and keeping it from, in some places, in some parts of the country, it's landfilled because they just don't have the outlet for it anymore.
Yeah, and a lot of the lumber mills we're actually paying to dispose of wood chips, and now we're actually taking their byproduct material and creating a very safe, environmentally friendly, high performance product. And I see Matt Blomquist just joined, so thank you, Matt. And if you wouldn't mind, we'll get you a quick little intro.
Yeah, sorry. I've set it up through my school email link, but now for some reason the school email is blocking the Zoom registration. So yeah, go around the back door, right? Yeah, Matt Blomquist here. I'm sure I'll jump in here a little bit later when we'll talk about the students using timber fill and timber bat on our student built project here in Taylorville, Illinois. That was designed by Emily Mottram. So whenever my turn comes around, that's what we'll discuss real fast. Excited to be on.
Awesome. Well, and let's go ahead and get started. And actually, I'm going to have Randy just kind of go through some of these different wall assemblies for code. I know he actually has a great blog post about kind of code minimum and how successful he was by just building to code. But some of these are now going to be the new code in many parts of the country. So 2021 code, I won't lose. I'll let Randy talk. How are you, Randy?
I'm good. Yeah, the code minimum, that's actually not on here.
Right.
In my market, and it's still commonly built in my market, is just simply a cavity insulation, typically 2x6. Well, always 2x6 in my market. and OSB sheeting, and then some kind of house wrap, and then the cladding. The article that Dan referred to, what we did with that one is just made it super airtight, which substantially improved performance of the entire structure. Pretty easy. But my preference is to add continuous on the exterior whenever possible. I like that. I like having a warm assembly. The two that are up here are actually part of the energy code. You see a 2x4 wall with a little bit more insulation on the exterior, a 2x6 with a little bit less. Now we can discuss getting into vapor retarders if you want, and I don't think we're going to go there. We'd be here all day talking about that one. But if you're looking to meet code, these two are pretty typical. You're going to want to definitely build to your climate. You know, my climate is in climate zone 7, and of course 8 are different than if you're in climate zone 4. Your amounts of insulation may be drastically different than what mine is. The last wall, you get into 2x8 and maybe even sometimes 2x10. That's still allowed if by the 2021 energy code, you're able to build without using exterior insulation. But they're requiring R30 in the cavity. Depending on the insulation you're using, you get into a standard fiberglass bat, for instance, you can't get R30 out of a standard. You might be into a 2x10 wall at that point to be able to achieve that R value. Of course, if you're using a closed cell spray foam, you might be able to get into a 2x6. Again, not my preference. I'd rather be more, like Emily said, more vapor open, move moisture through the wall more easily. And of course, the other two, you get into the double stud wall, which I think Matt and Emily are going to talk about pretty soon. And then the CLT, which I personally don't have any experience with CLT. That's you see that a little bit more in commercial and not so much in the residential yet. Maybe we'll see a little more in the future.
Yeah, we actually put the CLT because one of our co-founders, Matt Amelia, is an architect up in Maine and does a lot with CLT, and I know that, and it's coming. You know, and there's some great things about using wood as an insulator, not just for the thermal heat capacity, but, you know, many other options. So, yeah, I completely agree with you, Randy. You know, many of these options, it really does depend. And I did want to kind of bring up Matt, you know, so double stud wall, you know, why did you want to do double stud for this house? I know it differs on your projects, so.
So the ultimate true reason was because I'd never done one before. To get down to it.
Yep.
The second reason was because Emily presented us with the plans, which was awesome. Thank you again, Emily. And it was already drawn on there. So double easy for me. And the other thing, really, the biggest thing was my students really love the framing part. I think anybody that gets into house building, when we think about house building, it's always, we think of building a house, framing the house, right? That's what we always, you know, when you grow up as a little kid, that's what you think about, framing or building a house. And everyone always really likes the framing part. This gives the students a lot of hands-on stuff. So it was one more opportunity for us to put the, you know, tape measure, saws, the basic skills that they've learned. And the nice thing is when they're doing a second wall, man, I just sat back and watched. They you know, they've already framed the whole house. So it was just, it's really, those were my driving forces behind it. Or the perks, I guess. But it's one of those things where, you know, we're building high efficiency walls. So every house I learn more from what we do, whether it's the wall assembly contest that we do, whether it's webinars like this, whether it's just talking with friends that are in the you know, building science world. And I get intrigued by all of it, and I want to not be bored with work. So
Yeah,
got to do something different. So double wall was finally, I've been, ever since I watched Ben Bogey talk about it one time on wall assembly, I just like, man, I want to do at least one. So
yeah,
finally
and the students get to use the nail gun again.
Yeah, that's the thing. They love it. Everything about it's cool.
So awesome. And then I want to just kind of go back through some of these assemblies and just go through some of the details on here. So, Jason, if you wouldn't mind, just kind of walk us through these two different assemblies that are up on the screen right now.
Yeah, Matt pointed out this is a more recent code cycle with the 2x8 R30 in the cavity. You know, there's a couple of pathways. You can have just a prescriptive stuff, something in the cavity. You need an R value in that cavity, and that is, you know, mitigated, or there's benefit by adding that continuous on the exterior, because it bridges all of the thermal weaknesses in the assembly. So you have a cavity, you've got an R13 in this case, and because it's a 2x4 wall, you can add another R10 on the outside, and altogether that whole assembly is improved because you're covering the framing. What the 2x8 wall is kind of suggesting, as I understand it, is that if we increase that R value, it might be a 2x6, an R21. But if we get up to R30, it's almost like putting continuous insulation on the exterior. You're increasing the thermal resistance of the overall assembly. So there's some benefits to each method. Certainly there's some complexity when you start adding a significant amount of material on outside of your framing. And I think that's the drive for that 2x8 wall. I haven't seen a lot of 2x8 framing. I actually went to go pick some up for some of our sample bat testing, and I couldn't really find some local stuff easily enough.
Wow. Even in the state of Maine.
Yeah, you know, they had where the place I went had lumber that was not from here. So not sure what that was all about, other than it's a big stick. So, you know, there's some neat things that happen when you do double stud walls and you use what's available from what is harvested. As we continue to harvest more and more as sustainably as possible, we're still looking at smaller stock. Generally, we're not harvesting those redwoods, thank goodness.
And so, Jason, out of these two assemblies, which one is your favorite?
Ooh, well, I love complexity and trying new things, so I'm going to go with the continuous insulation on that one. I mean, Matt kind of teed that one up nicely. This is a little bit different.
Yep. And then, Randy, how about you? In your climate, too.
You know what? You've got one that's not listed on here that I actually like a little bit more. And that's moving all the insulation to the exterior. And
wait, it's coming up.
Is it?
You have to just these two.
He doesn't like any of these.
I want the other one that we haven't seen talked about yet. Yeah.
All right. So how about you, Emily, of these two?
I think that it depends, right? I know I said it, but when we are always talking about affordability and ease of construction and people doing it, the 2x8 wall is definitely more standard construction. So it is certainly easier for people to do. Although I'd add a rain screen to that one for our market. Simply because once you're getting to that 2x8 thickness, your sheathing is going to be colder. So the drying potential there. From a building science perspective, the 2x4 wall certainly is going to perform much better. But I like complicated things too, but that's not always the practicality of building. And I have to try to remember that as an architect. Somebody's got to build it.
Yep. And then how about you, Matt, of these two?
You know what? So I'm kind of on the last two houses we did were 2x6 with continuous insulation on the outside. So I'm pretty, like, honestly, continuous outside insulation, like, I don't know, you just use longer nails. Like it was no different than anything. So it's
What's
pretty
the average age of your crew, by the way?
By the seniors are turning 18 when I get, by the time they leave. So 16 to 18 is my people. The only thing with 2x8s, I would say that as a builder, obviously you have a deeper wall. 2x8s are just heavier. That'd be the annoying part of dealing with the 2x8, as far as framing with it. But I mean, I would consider both of these pretty simple. I would probably go with the continuous though, just because I don't know, a few small detail differences. It really didn't change much for us.
Yeah.
I guess now as
Awesome.
you guys get farther north than us, then it gets thicker. So then that may change things. But down here in 4, still in 4, we're able to, we used at that for that arc continuous, we used the zip
Inch and
R.
a half.
Yeah, I think the last one we used R9 because it was easier to get. So we're like, all right, what's going on there?
Yeah.
But yeah, which is 2 inches.
That makes a big difference too on where you are and what your local supplier has too.
Yeah.
All right. And there is Randy's favorite, kind of, with a CLT wall. So Randy, of these two, which one do you like better?
I like the open cavity, conventional framing with all the insulation on the exterior. But yeah, as far as these two, I would probably go with the CLT if I can figure out how to build with CLT. That would be the challenge, is learning a whole new construction technique, which I think I would enjoy. That'd be fun. Yeah.
Helps to have a crane.
I could imagine. Yeah.
And Emily.
Out of these two,
Yeah.
I love the idea of fully continuous exterior insulation, and I'd love to do a CLT building. They're not the cheapest thing, but it'd be
Yeah.
super cool.
Maybe for Matt's next project.
Okay, Matt, let's figure it out. Let's do it.
It's got to be different. I've never done one, so I guess that's what's next. I've told the kids at some point we'll probably do like a pre-panelized offsite assembly at some point, just because why not? And eventually they'll probably end up doing it that way at some point. So
Yeah.
that'd be
You
right up
could
the
have
bill.
them build the CLT itself. I mean,
Yeah,
a lot
absolutely.
of glue.
Yeah.
There you go. And yeah, so Emily brought up a great point before on the 2x8 wall about a rain screen, and we're not going to get too deep into it, but one of my opinions, or maybe it's probably my opinion. I don't know if it's fact or anything, but a rain screen really helps just with the drying potential of that wall. It really helps with the durability. If you could do one thing on a wall system to just gain some durability, I would say it's a rain screen. Or it's going to be an interior vapor control based on your climate zone. But that rain screen really does help. So what do you guys think on that one with the rain screen?
I agree. It should be on every project, or just about every project, even if it's one of the house wraps, the WRBs that has an integrated drainage into it. That helps. That's huge. I prefer to have the space back there so we get some drying, some air moving behind there besides. But just anything back there just to keep water moving down. Yeah, it's huge.
Yeah, we actually like those bumpy, crinkly wraps. And not just for the rain screen for your siding, which is a great idea to have that space, but also possibly behind the board itself. I mean, we're talking about wood, and we're talking about materials that can absorb moisture, and having a hard stop at some point for just bulk water. Siding's a big part of it. Siding fails. It'll get back behind that. It gets into your insulation layer, and it could wet and dry very easily with our products. And that's the benefit of having that vapor open material. But it's actually nice to have a little bit of that protection between the structure of the house, or the sheathing of the house as well. And we've got it drawn here with WRBs behind the board. That's a fine option. Crinkly and bumpy is better. Hopefully we'll have a little more texture to our board than some of the stuff we've seen from overseas. But that could also go towards the rain screen cavity as well. The WRB could go over the board, and then your flashing details get flipped around as well too.
Yeah, I would say the only place that a drying channel rain screen maybe isn't appropriate is if you're in a fire prone area. Then that becomes a different conversation.
Yeah, and for that application, I've done quite a bit in that area. Really using like a metal hat channel for your rain screen instead of a furring strip. The other thing is using like a cement siding or something non-flammable. is also really important there.
And a fire arrestor in your vent channels in case
Mhm.
you've got any kind of
Yeah.
airborne things that get pulled into it.
Yep. And then the one that we're going to be kind of diving into a lot more is the double stud wall. So I'm going to have actually Emily just kind of go through this. This is a typical double stud wall, I believe. And Emily, just kind of, can you go through kind of like the layering and everything?
Yeah,
And I
sure.
have your details too after this. So if you want, I could flip to yours.
No, that's fine. This is fine. We don't need anything more. So in a typical double stud wall from inside to outside, you'd have your interior finish, whatever it is, gypsum board, panels, whatever you're putting on. And then we like to have a vapor variable membrane on the inside of our double stud wall because the tighter that you build them, the more interior moisture is trying to get into your exterior wall. So this is going to be super thick, which means that our sheathing is going to be the coldest part, and it's going to be our vapor throttle, luckily, in our wall system towards the exterior. So we've got wood fiber in the interior 2x4. I think, Matt, you did two 2x4s, right? Yeah. So you can do
Correct.
two 2x4s, or in our market, sometimes we have a 2x6, 2x4 if we have a 2-story structure. So sometimes our structural engineer might want us to have 2x6 on the exterior, not necessary for 1-story structures. And then you will have a gap in the middle. It can be anywhere. I think with TimberHP, if you're trying to do your 5 continuous and argue with code that you have your R5 continuous insulation, you need probably about 1.5 inches. But we like 2 inches or some even metric there. You can make it as wide as you want. If you want to make a 14-inch thick double stud wall, go for it. That probably would be pretty difficult to dense pack, but go for it. So timber fill the whole way through here. You can either stagger your studs or you can line them up. If you line them up, sometimes that makes it easier for the insulator stapling the insul web, to create, 6 or 8 foot cavities. Through there. Then you have your sheathing. We usually have our WRB. In our market, we always are going to put on a 3/4 inch rain screen. So we've got a strapping layer, and then we've got our siding, which is also hopefully some kind of natural material.
And then Matt, how was the just building all of this? And you see some of the pictures, I believe, are these from the actual project? I believe that they are.
No,
I don't
this is
think they
different.
are.
Okay.
Looks very similar to ours, but yeah, it is different. No, yeah, I mean, building it wise was, and the reason we went with it was because I knew it was going to be something simple to, for the students to do, simple for me to kind of work with. Because remember, every time I have students, even if they're returning students, the last house they helped finish, so they didn't help frame, right? So they're brand new, no matter even they're returners. So it's something I want to be able to teach and execute with rookies very easily. So building it was simple. We did the 2x4 outside wall, 16-inch on center. We were only one story. Then on the inside, then we did a 2-inch gap. Inside was 2x4, 2 foot on centers, which was nice because then every 4 foot you line back up to a stud. So that's where we would cut off in our insul web to make the cavities for dense packing, so that it just didn't keep going sideways. And then we're going to go ahead and do the 2x strapping on the wall for the service cavity and stuff. So it adds some more lumber to it, but we use the Seeger Myrex as our our air barrier, and to help protect that. Plus, we found out last time when we did T-studs with dense pack fiberglass, the students, if you don't lean against the drywall when you're putting it up, you pop your screws, and the kids are like, the screws aren't sticking. Well, you got to learn to lean in, press tight, and put it in there. So the students had a lot of problems with that. So I was like, we're just going to do the strapping. It'll protect that SIGA. And since this time we moved our air barrier in compared to usually doing it on the outside. again, to do something different. SIGA's been a big supporter of us as well too, so they are helping us out. And then we can run our electrical and stuff through there. So it's yeah, ours is pretty similar. Pretty much what you're looking at there, just a couple slight differences. Super easy. I mean, it's basic construction, residential construction.
Now, Randy, in your market, are you seeing service cavities the way that Matt did with this project?
Yeah, most of my projects, at least on the ceilings, are all service cavities. The walls, were looking at a project coming up that is going to have an interior service cavity as well. 2.5 inches, I believe, is what the plan is. So that be something new for us. We're going to get quite thick on that wall because that's a 2x10 wall assembly with 2.5 outboard for one of the guys that I'm working with. So yeah, be interesting. Can't wait to see that one.
Dan, while you're on the screen too, I saw a comment pop in the chat box and I wanted to address it about getting pushback about blowing insulation behind, Myrex or one of the others. I should have said there is InsulWeb on here. You actually can't dense pack behind the SIGA. Those vapor variable membranes are meant to keep the air in, so they just blow out. You'd have to push a whole bunch of holes through it. So it is a two-step process. Unfortunately, InsulWeb first, that lets the air out, which lets you get a really good dense pack, and then we go over it with a vapor variable membrane. I'm sorry, that is not in my drawing. I don't know on there, I don't think, but that is, oh, it is InsulWeb, labeled in the wrong place.
Yep.
Look at that.
No, you're good.
No, it's not. It is in the right place. Those two lines just overlap. But so InsulWeb first to blow in your insulation, and then SIGA over top of it. So I thought while you're on the screen, you can see those two products, InsulWeb on the right-hand side, SIGA in the middle.
Yeah, that's a really good point too.
Question, Matt, how did you attach the Myrex?
So right now it's attached with the Twinette tape.
Okay. Okay.
But before we leave for the summer, since we're going to be gone for the summer, we are going to put a few of our strapping pieces up because it's a good temporary situation with that insulation and everything on there. But we can already see some spots where if the pressure is a little stronger and we got the Myrex a little tighter, it's starting to pop off the Twinette.
Okay, got it.
Yeah, I think
now,
that
if we were going right away, it'd already be done and over with. But
that point Emily was making, I think, is very, very valid coming from the install side of things. It really is, it's pneumatically driven material and it does need that pressure relief. So it is always kind of a shame when you end up cutting a bunch of relief holes and cavities in a air barrier that you have to then go back and tape afterwards. It feels like it's more work, but it's not. It's going to move faster because you've got that pressure relief. These are big cavities. You need a lot of movement. You need to be able to direct the material. And we do, for those that are interested in a little bit more of the details around install, we do have install video available in our resources section on our webpage, timberhp.com, and I think it's /resources, but it's pretty prominent on the site.
Yeah, and another figure that I heard also was the cost of the InsulWeb is much cheaper than the cost of tape to basically tape up all the holes that you need when you're, cutting relief valves. And actually Randy has a great, he was doing a blower door test on a house up in his neck of the woods in Minnesota. And you could see, I believe it was in Tello, but with just the pressure and there's no air coming through that assembly.
Yeah, it looks like a big pillow.
Yeah.
It just popped out. Yeah.
Yeah. But no air.
Ty Newell was just on the job site with us again today. Emily knows Ty. And I was showing the inside real fast, and I literally made those same comments about the InsulWeb. Like you get a whole roll for, I don't know, $100. I don't even know what it was. It was cheap, and we had tons left over. Like it's nothing. Like you just get buy tons of staples.
Yep.
You get a pneumatic one.
Yeah, I think, Awesome. And then one question for you, Matt. after installing it, how has the sound been? Because you also have some nice triple pane windows as well.
Yeah. The only thing, yeah, it's I mean, when the seniors left the last day and they went rip roaring out there with their trucks and stuff, you could still hear that. But I guess they're excited for the last day. But no, it's yeah, I mean, it makes a difference as soon as being that thick of, we have what, a 9-inch thick wall with fully packed. It's even the kids and people walk in and they're like, it's so quiet in here. And I mean, it's not like you can't hear nothing outside, but
Right.
and then when we're putting in windows, you're trying to get attention of the kids outside. You literally have to open a window and holler outside. I can't just yell at the kids outside the house when I'm inside the house and they hear me now. You got to actually open up a
Open a
window and
window.
stuff. So yeah.
Yeah.
So no, it makes a difference. Plus, and then we have a whole room done inside there with the timber bat. So you walk inside of that thing and then, so it's starting to get quiet in there. So next year, if the kids want to hide out from me, I'll have to really go hunt them down. I won't be able to hear them.
And then I hear we have a question. So Bill, if you're on.
Yes, so we do have a question. It is from John Lyon. Have you looked at a modified Larson truss with TJI or comparable outside, 10 to 12 inches of dense packed timber fill and 2x4 structural wall, smart vapor membrane, on the inside, as compared performance-wise as it would compare to a double stud wall?
I've done something similar to that. Works great. Built it in the factory, came as a panel. Absolutely amazing. It's great because it basically already has a service channel in it. If you were going to field build that, it takes a lot more time. We're going to do something similar on another one of our projects coming up here. Larson trusses are fun. They're awesome. Eye joists aren't super straight, and you're also only nailing through one side of the eye joist. So if you've ever seen how they're kind of put together, you're only kind of attaching it to the one part so the flange itself can come out. So it's a cool idea. Lots of different ways to do Larson truss. I think there's a Larson truss detail in the book as well. Jason, do you guys have one in your manual?
Not yet.
Yeah, I know we had talked a little bit about it, but there might be something with a CLT or something along those lines, but it's not real apparent. Essentially having that cavity to fill on the outside. But
Awesome.
it does get a little bit more complicated, and you are talking about a very deep cavity, which also needs more detailing and all of that when it comes to dense packing in any fiber. But certainly with the complexity of the fiber length with timber fill, you really need to be able to work that cavity to make sure you get your densities right.
And then what's on the screen now is because, it could get a little confusing on some of these, like this one, the bottom of wall detail. Emily, would you mind just kind of going through what the detail kind of looks like, what those layers are?
Sure, and it's actually showing two different ones here. One with the slab where it's actually just, you can't quite see it under there, but it's not sitting on the plywood plate on the bottom. But part of the reason we do the plywood plate in our market is we need a lot of insulation at the slab edge to thermally isolate the slab from the frost wall. And also too, if you're going to blow in timber fill into this wall cavity, you want to make sure it's not touching your concrete slab so it doesn't absorb any moisture from the slab itself. At Matt's, they actually built a frost wall. So they built it on a floor system, which changes the detail. Makes it a little bit easier for the 2x4 wall because you're not trying to hide whatever your rigid insulation is on the bottom of it. The plywood gusset on the bottom also can tie your two walls together. Sometimes that's necessary, sometimes that's not necessary. We've built it on a 2x before, but then you have a thermal bridge at the bottom of your wall, which is significantly more than this. So there's just a lot of when you start playing the building science game, a lot of thermal isolation in our market in zone 6 and higher. So essentially this is just showing those two separated from each other and how it might sit on a slab, which is a little bit different than how it sits on a frost wall.
And then Matt, how did you guys address your project?
As far as like foundation to wall, or
Yeah, because it is, I guess, slightly different with this.
yeah. So ours is we use the Perfect block. If anybody's seen it, which is an ICCF block, a little bit different than a traditional ICF block. But if you guys look at Perfect block, it's a pretty cool product. The kids did a whole self-perform thing, and I believe we with that gives A, used less concrete in the foundation, and B, I believe that gives us an R27 for our foundation walls. And then after that, I mean, it was a pretty typical install. The only thing we had to do was where my original thought was using exterior insulation as well in a double stud. But then I know once you start getting so thick, then you have to kind of worry about where moisture happen or condensation and stuff can happen on the inside of the wall and stuff. So we opted not to go with that. So, but in our crawl space against our wall, we have insulation that'll be built out as thick as our wall underneath as well too. And obviously we air seal and tighten everything up. In fact, if you guys have been watching my Instagram, we were playing around in the crawl space this week while it's been raining and smoking underneath plastic inside of the crawl space and all kinds of fun things. So that's how it was. I mean, I would call it a pretty typical crawl space detail. We just had to kind of take care of a few things compared to what Emily's plans was, which was on a slab, which I mean, didn't really complicate things more for us that bad. It just changed little things from what was drawn. So I had to stop and think for a minute on a few things real quick. But you know, we followed the kind of same rules, try to air seal the red line test and all that, and keep thermal bridging and everything to a minimum. So the only thermal bridging we truly would have now is the I-joist, floor joist, the OSB. I guess that'd be what the gusset or whatever for us, to touching the rim plate or rim board, which then has the sheeting on the outside. So that'd be the true only thermal bridging we really have in the whole house. And Emily and I both agreed that was probably pretty minimal, meaning that OSB is not gonna do a very good job at bringing that heat in. So
I don't know if you have that one. Do you have that detail? Do you have a truss detail? Oh, well, sort of, but that's not exactly what his looks like.
the truss detail or the floor detail?
The floor detail. Yeah.
I don't think.
So.
Yeah.
I say the truss detail will be exactly what you're looking at right there.
Yes.
Yeah. So if you guys want to go through the top of wall detail next.
Sure. I mean, for us, we just double wall. We took scraps of our zip sheeting, 1/2-inch zip sheeting. That was our gusset on top to tie the two boards together or two plates together and to keep the insulation from going up, and also you know, fire draft stops and all that good stuff. And then we sat our energy heel truss just like the picture there you guys have in front of you. And then we will in fact, all the timber fill that came out when we were doing dense pack is all gotten dumped into our attic, so we didn't waste any. And next fall, once we're done running utility or piping and any wiring that's got to go in our attic, we won't have any duct work or anything up there, of course, because that's outside of our controlled layers. Then we'll take the rest of the timber fill that we got here on site, and we will blow it into the attic, and about 20 inches deep. So we'll be somewhere probably just shy of 60, R60 up in the attic. So it should be nice and cozy. And ultimately, we also build our catwalks above in our attic at 20 inches high. We build catwalks all the way down. So that way, when we are working up there, or anybody would ever have to access up in the attic again, they at least could walk above the insulation before they have to go digging through 20 inches. So that's pretty much the attic, man. It's pretty simple. And then, of course, our Myrex is on the inside. So that was our air barrier. And then it is a vented attic. I will do a post on, I just did a video on what we did kind of special with a detail from Bob Kelly that provided us with our top ventilation detail and stuff. So, but it's a vented Yeah,
Oh,
cold attic.
awesome. Yeah. And I actually see Bill's on. I'm sorry, I have like 5 people on mine. So Bill, if there's another question.
Yes, we've got a question in the chat from Charles Kelly. So if I were building a double stud wall assembly with a 3-inch gap, rather than blow-in timber fill, can I use timber bats?
You can, yes.
It came in a little earlier when I was typing an answer to another question, so I didn't know if there was some context around that I had missed. So I wanted to make sure.
I think if you
Yeah.
did that, Bill, the only thing you'd have to do is you'd probably have to build the first wall, pack the first wall with your
Yeah.
timber bat, put the next layer on, then sandwich it with your framing because you're not going to get that wiggled in there like you would a
Right.
good install. But it'd totally work. I mean, you just have to keep that next row, the in between row, up while you're framing or whatever. You'd have to come up with a system or fasteners to do that. But I
In
would see
which
that
case,
the only challenge.
yeah, if I was going to do that too, and you're going to build your second wall after, I would put my Siga Myrex on the outside surface of that interior wall before I stood it up against it. So you could use your interior 2x4 wall as your cavity without getting into your air control, a vapor control layer. And as long as you're in a colder climate, that would still be the right part of the wall system.
Which leads us into another question. Parker Brown asks, Building Science Corporation recommends sheathing on the outside face of the interior stud wall with joints taped to limit moisture in the middle of the assembly. Thoughts?
I'll touch on that, but maybe we could get some input from Emily and her opinions on double stud assemblies. This is referencing building science white paper, and it is actually a very suspiciously similar assembly in our builder's guide, with the gray being a little bit more yellow, replacing the cellulose. But for those that haven't looked at the link or don't know the link, but we're talking about a double stud wall. We've got a 2x on one side, a wall, and a 2x outside wall, if you will. But in the details that building science promotes and also supported the builder's guide. Essentially, there's that sheathing, that structural sheathing down the middle of between those two walls. And I think it kind of leans into a little bit about what Emily was suggesting by having the air control down the middle. Building science recommends taping that. So essentially it's almost like a continuous interior cavity, continuous exterior, if you will. It's separating those two. Belt and suspenders approach for sure. I think the concern with some deeper wall assemblies is the drying potential, especially you get into the colder climates. So Emily, you touched on that a little bit, but how comfortable are you with the deeper wall cavities in these cold climates when we talk about double stud cavities?
Well, I mean, there's definitely it is a slightly riskier assembly than the perfect wall or continuous exterior insulation. Although way back a couple slides ago, when you asked about the CLT wall or the 2x6 plus R5, that actually doesn't work in our climate zone, even though it says you can do that per code. Anyway, that's a different story. Here, the question with the sheathing is we often use sheathing in our assemblies for shear, which would make the interior wall your structural wall, which isn't a problem. It just changes some of the details in your load paths for making that your structural wall. You could do that in the center, make that your structural wall. You could tape that, so you could use zip in the middle. You could tape the zip. It could be a good air control and vapor control layer. It's on the warm side. You'd still have enough insulation to the outside of that. And then you can actually eliminate the insulation on the sheathing on the exterior, because you don't need that anymore. So you could put sort of like a Mento over it. If you need to insulate that in the field, it adds a lot of complication, because I'm sure that most people will tell you that kind of doing that install and then not covering it and sort of having your insulation from the outside can, hope it doesn't rain sort of thing, because again, you got to put it in with something other than than your water control layer. So then you got to make sure your water control layer is tight. So it's good. It's definitely belt and suspenders from the science point of view. That really works. You could put a layer of continuous wood fiber board on the exterior of that, which would be kind of a nice detail. So yes, you can. In a double stud wall, I think it makes it more complicated. And if I was going to do that, I would probably be looking at continuous insulation or a Larson truss system instead of building a double stud wall.
And then, Bill, did you have another question?
I do have a couple more questions. We've got one from an anonymous attendee, slightly different from the double stud wall conversation we're having here, but to achieve an R30 in climate zone 4A, can we use continuous insulation board on the inside of a 2x6 framed wall, since their GC does not want to alter existing exterior siding and trim details?
I'm going to see if Jason can.
I was gonna just say it depends, but
Yeah.
well, I'll think about that live. I mean, we're adding continuous on the interior. So it's got to depend on the ratios. So you need a certain percentage inside and outside, but it's flipping things around there. So yeah, I'm not sure about that. I mean, I get the effort. Usually it's not done because you're stealing that condition space. That's usually the part where people don't want to add material, you know, and lose floor space, square footage. But I think it could work. I think it's just very unconventional, a little backwards, and it'd have to be very careful about where your air control and what is on the outside. If it's a existing condition, what is behind the siding? What is the sheathing? You know, how permeable is that? And are we setting something up because we're trying to avoid the existing siding? And the unknowns would need to be sussed out a little bit more, I think.
I would feel also that like outlets, switches, cabinets, things that you're securing through that would be very difficult to do. Randy, what's your take on that?
We did something like that on that barn dominium project that we had, where we had a cavity insulation, you know, just regular fibrous cavity insulation. And we also had a fibrous board insulation that was in between, but that was all strapped. So we had 2x4s every 2 feet, and then we just filled in. Electrical happened to go there. So kind of a continuous, but it was broken by lumber. It
Yeah,
works.
and that was a post frame too, so you had a lot less thermal bridging anyway.
Yeah. Our framing was 6 foot on center on that one. So yeah.
And then I'm going to actually just skip to the next slide because this I think is something that is a question I get a lot is windows. And what do we do around windows with double stud walls? Whoever wants to answer.
I'll go first. The middle picture on the bottom is our picture. So that's how we handled it. So when we did our interior wall framing wise, the students went and lined up the framing members of the window first. Because I said, let's make sure the window's right. Now, Ben Bogey had suggested making it slightly bigger, just so you have that. Because I told the kids, I go, if we mess up, we want to mess up wide, not skinny. And he suggested when they do their double stud, they go out a little wider, and then that way for their jam extensions or well, I guess what you would call it, I'll just call it jam extensions. The connecting boards there. So pretty much what we did was we put zip scraps on the inside, just like we did on the top, and that was our window box. It was 1/2 inch and stuff. Now we also didn't do a inset window. Ours was still a flange window. If we were going for bigger things like passive house certification stuff, I think we'd have to move inward and have an interior window dug and I, who provided the windows. We used Alpine Euro style tilt and turns. We went ahead and did with flange and felt pretty safe with all that. We've done all flange on all our other builds and stuff, and had zero issues and stuff. But like I said, if we're going to the next level, I think we would have to move in, and maybe that would change. Maybe you switching out to a 3/4 inch board around there just for some securing purposes. But for us, it was literally a way to block insulation from falling into the window, cutting that all off. Obviously, we were able to tape it, zip tape it for air sealing, and then we wrapped, it's not in this picture, but if you watch some of my other more recent Instagrams, you may see the picture of the kids wrapping the Sega around, taping the Sega wrap to that plate all the way around, and detailing it like we would on the outside. Instead of controlling moisture coming in, obviously this time is air sealing. So that became part of our air barrier as well. That's also taped around. So that's how we handled it. Very simple, cheap. I don't even think I bought an extra piece of sheeting. It was just what we had left over to do the windows. Anyway, saw and nails, that's all it took. Just whenever you frame your windows, just make sure everything lines up like it's supposed to, which the kids did a good job. So it worked out pretty easy.
I agree. I appreciate that you guys did that. I actually threw a couple of these in here because this is how some of our other contractors have attacked this. And as you can see, it's not always the easiest solution. We recommend the plywood box. And as you can see in the detail, that would be an inset window, and we go to 3/4 inch on the bottom. So you can put the window wherever you need it to be in that window opening. With our walls being a little bit thicker in our climate zone and having 2x6 exteriors, we'll often align them with the inside surface of the exterior 2x6 wall. I like the plywood detail. I think that makes a big difference, but you can see that other people have taped it in to the outside surface, done a flanged window, or done a full membrane in the window. I like the plywood buck. I think it solves a lot of problems.
Just when you're doing your rough opening, remember you're doing that.
Yeah, make sure
Yeah.
it's big enough for that.
Yeah.
Playing that, yeah. Don't just go, 34.5 inches. No, it's 35.5 inches or whatever.
Mhm.
So
Yeah.
remember that detail.
That sounds
We
like
did.
one of
Thank
those
God.
"don't ask me how I know" responses.
I was very thankful that I thought ahead of it, because otherwise it would have been that story. The kids would have learned some remodel work.
Randy, it seems like you have a horror story on that one with the window buck.
No horror stories.
Okay.
We were good. Not yet anyways.
And then this is just like a quick video of the house. It got away from the house real quick, but this is actually, this is my horrible drone skills, by the way, because I haven't used it in a while, but that's the high school. And you saw exactly where the house was. So Matt, it was really cool being on this project with you and the students, and watching them just literally being able to walk from the school to the house.
Well, they get bused from the school. So the school you see there, that was the elementary school.
That's
Yeah, but we're still literally right down there. I mean,
yeah,
it's less than a 5-minute bus ride. It's very convenient. I can walk from my house.
nice. Yeah, you're right behind here, right?
Yeah, pretty much walking half over. Actually, probably one of these videos you probably can't see my house probably from it. But yeah, that's the job site right there. The if you guys see the solar panels over there in the corner,
Sorry.
by the yellow trailer, that's our mobile
Yeah.
classroom. Students built a mobile classroom when we kicked off this program again. It is me and the teacher friends from the Shop Class podcast all came in this summer, and Greg from NIACC up in Iowa, and some of the money I won from the Harbor Freight Tools for Schools teaching prize. This whole house has been built on solar right now. That's our power generator. That is our temporary power. We currently do have permanent power going to a meter base, but there's no wire connecting from outside box to the inside box at the moment still. So
Nice.
everything we've done, batteries charged, everything's been off solar, which has been pretty cool. Kind of a cool thing to say and do. And this house, our friend Ty Newell is working on trying to work on connections with potentially putting solar on this, but at the very least, it'll be solar ready. So in fact, we just started working on the standing seam roof, but we are dodging raindrops every single day, seems like. So
Have we done a beam calculator, carbon
not yet.
on this
Not
with
yet.
not using any, solar power, the foundation, no slab in the
Yeah.
base, in the crawl space?
Not yet. Oh, someone asked me that on either LinkedIn or Instagram the other day, and we have not done that, but I would be interested because we've obviously using Perfect Block. I think you cut the concrete in the foundation by like 60% or something.
Mhm.
In fact, we almost had just as much concrete in the footings as we do in the walls. There's only a couple of yards more, which is pretty crazy. I know it's just a crawl space wall, but it's pretty impressive. And the rest of the concrete was just in the garage floor and the porch caps area, and then obviously whenever we do our driveway. But yeah, our workforce gets shuttled on a bus every day, so I'm sure that factors in and helps. We've had the power sources from the sun. Yeah, I don't know, it'd be interesting to see. It's going good. It's been fun to kind of tinker around and experiment and let the kids kind of learn about all that stuff as well too, and for me too, learning as I go as well.
Oh yeah. And then I did want to, before we get to any more Q&A that we might have, I did want to bring up, because a lot of you out there are wondering, where do I buy TimberHP products? So now if you go to our website, timberhp.com, you could just top right corner, it says basically dealer locator or where to buy. And this will come up, and it's growing exponentially, which is very great. We're right now, you can kind of see we're up in Maine, in the New England market, mid-Atlantic, Midwest, even out to California. So we are growing this. So if you do need any additional support there, please feel free to reach out to myself. My email is up on the screen right now. Also find me on Instagram. If you have any technical questions, I did throw Jason Todd's email up there as well. He's our director of building science. And then, Matt, where do you find yourself, online?
Probably the quickest and easiest, obviously, if you're on Instagram, build, learn, teach, there's underscores in between each word. And then I stay pretty active. I do the same thing over on TikTok. If I know the younger crowd likes to be over there, and we're all catching up, I guess, on TikTok. It's the same, build, learn, teach. And then if you're on LinkedIn, my Matt Bloomquist, whenever you put in Bloomquist, it's just one O in the last name, even though it sounds like there's two O's. I'm pretty active on LinkedIn and stuff too, and there's a lot of good conversations that happen on my post, which is always fun too. I love that people engage with me over there as well too. So, or reach out to any of these people. Most of I think Randy, Emily, and Dan all have my contact information too. So if you have their information, they'll feel free to pass it on. I don't keep it a secret. Or if you really need to get me, call the Taylorville High School in Taylorville, Illinois, and they'll get you. So.
And then Emily, how about yourself?
Probably the easiest way to get a hold of me is, well, I'd like to say that I do Instagram and LinkedIn fairly regularly, but I'll tell you that my admin does it. So, but if you leave a message there, it'll still get to me. I do check it and find all the cool stuff that everybody else is kind of up to, but I'm a little slower on social media these days. My website is a great way to get through to me, matrumarch.com, because architecture is too hard to spell. You can send me an email, emily@matrumarch.com, or you can see me on the BS and Beer Show live on Thursdays. And a couple of great women in construction events coming up, so stay tuned. We'll be out in Denver, down in New Hampshire for SIGA, so a couple of other fantastic events coming up. I'm not hard to find.
And then how about you, Randy?
You can find me on Instagram. I'm Northern Built Pro. And I also write a blog. It's www.northernbuilt.com. pro. I do write for a few other spots too, so you may see me from time to time in Fine Home Building, GLC, or Green Building Advisor.
Awesome. And then Bill, we're going to take one more question, maybe two.
Well, I've got a doozy.
Okay. Yeah.
So
Shoot.
it is
Those-
a roof. It's a roof assembly question.
Oh.
So for roof assemblies that will
That's
be
July. No.
will be non-vented and dense pack. Think super insulated roof at R40, if I'm reading that right. Is there anything special needed besides some solid strapping on the inside?
Event.
Mhm.
Gonna say venting.
Oh, sorry. 40 inches deep. Goodness gracious.
40 inches deep. Wow, that's a big roof.
Event on top of the roof.
Yeah. Can you even dense pack 40 inches, Jason?
Parts of it will be dense packed, yes. Yeah. I mean, assemblies like this are, more power to you for the R200 assembly or whatever that math works out to be. Deep cavities are hard. The deeper you go is harder with dense packing. We get questions around roof assemblies and I don't want to jump right back in after we were working our way back out, but the builder's guide touches on some of that, and I think we've got more work. It's really about the ratios with condensation control, and if you can kind of split that assembly, it can be an unvented roof. And the code does a pretty good job, although Randy will say that things have changed a little bit and there needs to be some adjustments in those ratios or R values, if you will, in the 21 cycle. But yeah, it's really about good airtight assemblies that can still release some moisture when it does get in incidentally, one way or the other. And I think they can be done. Unvented assemblies can be done, but boy, that's a doozy.
Yeah, that's an R60 or 160. So that sheathing
160,
is
did the math.
very cold. Definitely
Yeah,
a membrane underneath, and I would say even vapor permeable above that with a vent on top of the roof.
Yeah. There's
And then but it's still technically then a vented roof. I know Fine Home Building did something like that.
Yeah, someone just mentioned a diffusion port, and there is stuff in the code with the warmer climates with the diffusion port, and I think that is something that we would recommend in even colder climates that allows any moisture that would happen to get into that assembly to be released. It's a weird little thing that's new. It doesn't typically get installed in the colder climates, but because we have such a permeable product, if there is some condensation issues, it's going to make its way to the ridge. And if that ridge is airtight but vapor open, that would be the suspenders to your belt.
And or a vapor diffusion port in climate zones 1 through 3 only.
Yes, that's code approved, signed off, ready to go. But yeah, I think it could expand with these new products that are coming to market like ours.
Awesome. So any final thoughts from anybody?
Thank you again,
All right.
TimberHP and Dan, for coming, and Emily coming to the job site with the students. That was awesome.
Yeah, it was so much fun. Made me kind of want to stick around. Put on a tool belt, hang out.
Yeah. And some of the best Indian food is in Springfield, Illinois.
Wow.
That was
Excellent.
fantastic. So
Yeah, who knew? I had no idea.
yeah. So, all right. Well, thank you, Randy. Thank you, Emily. Thank you, Jason. Thank you, Matt. Thank you, Bill. Thank you, everybody, for joining and sticking around. I know we're over time now, but I guess basically next month we're going to be going through another great topic. So we're going to be, because you signed up, you're going to be getting those emails as well. I don't know what's happening to my camera.
Wow, Dan.
All right,
Awesome.
Dan.
I'm about
Good
ready
for
to
you,
go do
man.
disco, apparently.
Not Friday
So,
yet.
Yeah. Let's start calling you Prince.
yeah, I don't know what's happening. All right. Well, thank you, everybody, for joining.